Okay, let's see.
Okay, there you go.
So maybe we referred about cerebral cortex, but we just because it's been a real while, so let's continue more a couple of times. Okay.
Mhm.
When most
Okay.
people think about the human brain, they think of and picture the cerebral cortex. So it is kind of like when you think of the human brain, it's usually it is referred the cerebral cortex, and it is gray wrinkled surface of the brain. Is actually a thin layer of densely packed neurons. So there are hundreds of thousands of neurons here. This layer covers the rest of the brain, including most of the structures we have described. When we are born, our cerebral cortex is full of neurons. So they're all like mixed. More than we have now actually, but the neurons are not yet well connected. So it's all disconnected. As we develop and learn, the dendrites of the neuron in the cerebral cortex grow and connect with other neurons. This process forms the complex neural web you now have in your brain. The surface of the cerebral cortex is wrinkled. The wrinkles are called fissures to increase the available surface area of the brain. The more wrinkles, the more surface area contained within our skull. If our cerebral cortex were not wrinkled, our skull would have to be 3 square feet to hold all those neural connections. So here, and next part is hemisphere. The cerebral cortex is divided into 2 hemispheres, left and right. The hemispheres looks like mirror image of one another, but they exert some differences in function. The left hemisphere gets sensory messages and controls the motor function of the right half of the body. But whereas the right hemisphere gets sensory messages and controls the motor function of the left half of the body, it is almost like cross. This
Mm.
is called contralateral control. Yeah. So researchers are currently investigating other differences between the hemisphere, such as the possibility that the left hemisphere may be more active during logic and sequential tasks, and right during spatial and creative tasks. However, these generalizations need to be researchers further before conclusions are drawn. This specialization of function in each hemisphere is called brain lateralization or hemispheric specialization. Most of this research in differences between the hemisphere is done by examining split brain patients and patients whose corpus callosum callosum, the nerve bundle that connects the two hemispheres, has been cut to treat severe epilepsy. The operation was pioneered by neuropsychologists Roger Sperry and Marco Canzaglia. Split brain patients also cannot orally refer to information only presented to the right hemisphere, since the spoken language centers of the brain are usually located in the left hemisphere. And then next one is the area of the cerebral cortex. So when you study the cerebral cortex, think of it as a collection of different areas and specific cortices. Think of the cerebral cortex as 8 different rows, 4 on each hemisphere: frontal, parietal, temporal, and occipital. Some of the major functions of this part of the brain that are relevant to the AP test are mentioned here. Any area of cerebral cortex that is not associated with receiving sensory information or controlling muscle movement is labeled as an association area. Although specific functions are not known for each association area, these areas are very active in various human thoughts and behavior. For example, association areas are thought to be responsible for complex, sophisticated thoughts like judgment and humor. And there is a frontal lobe. This part is really important, and this is large areas of cerebral cortex, and which is located at the top front. Here, top front part of the brain behind the eyes, this part.
Okay.
The interior or front of the frontal lobe is called the prefrontal cortex, and is thought to play a critical role in directing thought processes. So let's look here. So this part is frontal lobe. So your eye is here, this part. Your eye is here, and then back to the top of the eye and backside there is the frontal lobes. And here motor cortex and sensory cortex. And here peripheral lobes and occipital lobe. Here and temporal lobe. So there are many lobes of the cerebral cortex. It is thought to play a critical role in directing thought processes. The prefrontal cortex is said to act as a brain's central executive and believed to be important in perceiving consequences, pursuing goals, and maintaining emotional control. So, cause of this control, emotional control, this part is really important. Researchers believe this part of the brain is responsible for abstract thought and emotional control. So if somebody like harm from like this party, he or she cannot easily control their temper. The story of Gezi mentioned previously exemplifies some of the function of the prefrontal cortex. And Gezi's limbic system was separated from his frontal lobes in an accident. Doctors reported that he lost control of his emotion and became impulsive and animalistic. So these frontal lobes make human more humanistic. In most people, the frontal lobe in the left hemisphere contains one of the two spatial areas responsible for language processing. Some left-handed people's language centers are in the right hemisphere. It is almost like a cross. And there is a broadcast area is in the frontal lobe. Is responsible for controlling the muscles, which is involved in producing speech. So if you damage to the broadcast area, might leave us unable to make the muscle movement needed for speech. And the other area is Wernicke's area, and also which is located in the temporal lobe. So it is behind the frontal lobe. So Wernicke area is here. Temporal lobe is here.
Below the frontal lobe.
Yeah. So a thin vertical strip at the back of the frontal lobe. It is farthest from the eyes. It's called motor cortex. This part of the cerebral cortex sends signals to our muscles, motor cortex, and controls our voluntary movement. The top of the body is controlled by the neurons at the bottom of this cortex, processing down the body as you go up the cortex. So the top of the motor cortex controls the feet and toes of the body. And next one is parietal lobes. Parietal lobes is again, let's look here. Here, this part, parietal lobe. So let's look. Parietal lobes are located behind the frontal lobes, but still on the top of the brain. Maybe you can see the picture, this one. And parietal lobes contain the sensory cortex. They contain sensory cortex, also known as somatosensory cortex, which is located right behind the motor cortex in the frontal lobe. The sensory cortex is a thin vertical strip that receives incoming touch sensation from the rest of our body. The sensory cortex is organized